Hey everybody, let's get started on Unit 4. This is Video 1. You're going to get an introduction and some vocabulary for graphing the trigonometric functions. These are the vocabulary words that we're going to work with, so go ahead and jot them down. And then I'm going to give you an equation for both sine and cosine, which is kind of our standard form, and you'll see how we're going to apply all of these words. So go ahead and take a moment to jot these down. We have amplitude, period, phase shift, sometimes called the horizontal translations, vertical translations, and reflections. Now I know you've seen the horizontal and vertical shifts in algebra, and you've also seen reflections, and those are going to work very similarly here in trig. So the first thing we're going to work with is our amplitude. And amplitude basically takes the graph and stretches it vertically. So this is our vertical stretch or compression. So if A is a large number, like 7, then we're going to take this value that is currently at 1 and at -1, and we're going to stretch it all the way up here to 7. So any value that you see at these maxes and mins, they get stretched really high and really low, depending on what I change A to. If I were to change your A value to something like 1/2 or 1/3, which is less than 1, then I'm actually going to compress this function and it's actually going to get a bit shorter. So what we need to remember about our amplitude is, other than it being a vertical stretch or compression, is that it also changes your maximum and minimum values. Because our maximum is currently on our standard graph, and this is the graph of f of x equals the sine of x. And this is our graph of cosine, and that's going to be the same on all of the slides, so I'm not going to write that on everyone. But the one on our left here is our sine, and the one on the right is the cosine, the standard graphs. So it does change our maximum minimum. The other thing that this amplitude does then is it changes our range. So if we look at our range for both of these, the high point is 1 and the low point is -1, making our range between -1 and +1 inclusive. If we were to change this amplitude, then this value would change because our numbers would either get shorter or they would get much larger, and they would end up looking like this, or like that. So that would definitely change our range. The period. The period change is our horizontal stretch or compression. And our period, I'm going to show you on the next slide, does a little strange thing when we have to do the stretches and compression. But the idea behind this is it's the b value that you see here in front of the parentheses in front of the x. So let me give you a little look as what it might look like. If I have f of x equals the sine of 2x, then our b value is 2. Or for example, if I have f of x equals the cosine of 1/4 x, then the b value equals 1/4. And that's regardless if this x is in parentheses or not. That does not matter. So the b value is what we're pulling out. Now here's what it does to the graph. If my b value is large, it actually shrinks. This is a compression. And if your period normally takes you from 0 to 2 pi, I hope that 2 pi sounds familiar, maybe like around the unit circle, and I decide to compress it, I'm basically squishing it down and saying this whole thing has to occur in pi radians. So I'm actually compressing it. However, if I decide my b value is a fraction, like this 1/4 here, then I'm actually stretching it. So this is a stretch. And I don't remember, I'm sure you were told, but if you remember in Algebra 2 that your horizontals, we use the reciprocal, and that's very similar here. So this one I would actually take it and it would happen in a much larger way. So it would not take just this 0 to 2 pi to complete. It would actually go all the way beyond 2 pi. So as we continue with period, what we do is we take 2 pi, our standard period, and we divide it by the b value. And this gives us our new period. And the period is, again, the time it takes to complete one full cycle of the trig function. Okay, and 2 pi is the standard period. Next up is the phase shift, or our horizontal translations. And these horizontal translations move us left and right. If you remember, if we have a plus h, then we know we're going left. But if we see minus a value there, we know we're going right. So it's always the opposite of what's inside with the x, just like it was in Algebra 2. So these would basically take every one of these points that we see on the graph, and we really typically use those 5 points, and it shifts them. And sometimes it's really awesome to have a second color pen available, because I'm going to shift these all over. And this becomes our new shifted to the right sine curve. And if I were to shift to the left, I could take each one of these points and move them to the left. And that is our horizontal translation, or phase shift. Next up is our vertical translations. I'm going to go back to red. Our vertical translations move us up and down. So up and down. And just as with algebra, if it's up, it's plus, and if it's down, it's minus. So that does not change. And that basically takes this, and I like to use this center line here. We'll do more in class, but I like to move the whole center line and then make my curve mimic that as if that was the new axis, even though it's not a new axis, but it does give us a place to graph it. And if I were going down, I might move this here and say, oh, my new graph looks like this. Again, kind of using that axis to help me recreate the curve. So vertical translations move us up and down. And last but not least, we have our reflections. Our a value is actually always positive. It's whether or not the a value is being multiplied by a -1, or if it's being reflected. So if it's negative, then we know it's being reflected over the x-axis. Okay, so we actually would take all the values that are here and we would move them, and any value that was on the x-axis gets to stay. And so my new curve would look like this. And all of these values that are not on the x-axis get to move and flip over, but the ones that are on the axis get to stay. And here is my reflected cosine graph. So we look forward to working together in class, I'm sure, because now you have just gotten a little bit of the basics. So we're going to start very slowly moving through these, and bring any questions you have or post them there on Schoology.